Hello everyone. Today we are studying a new unit that's going to focus on lights. Okay. This first section covers majority electromagnetic radiation, but we've already covered that in a previous unit. Okay. To summarize, if you remember, there are seven different types of electromagnetic radiation, and all of them are considered to be light. You have radio waves, which are the weakest, and then going down, they get stronger, with gamma rays being the strongest. And at the right of this table, you have different applications, and we've already done the calculations for this stuff. So I'm good with this section. We're not going to go through it again. What I want to focus on is this instead, which is illumination, lighting, brightness, whatever you want to consider it. I find this to be very interesting just because it is very dependent upon the environment and the individual. And I'll give you an example. So, illumination is essentially how bright something is and how much light you get from it. Like, let's say you're on your phone. You're on your phone inside your room in your house, and all the lights are on. So you're in a well lit room, right? Your phone screen doesn't bother you, right? It's normal. It's a normal brightness. You can look at it. It doesn't hurt your eyes. Everything's cool. But now let's say you turn off all the lights. All the lights are off, and the only light source in the room is your phone. And without making any adjustments to the phone, you didn't increase the brightness, you didn't lower the brightness. Now the phone seems brighter than it was before, even though we didn't change anything. All we did was turn off the lights in the room. But now the phone seems brighter. And now it might hurt your eyes, depending on the individual. So you can do these calculations to figure how bright something will be, but depending on the situation, the environment, that number may or may not mean anything because you may do a calculation that says it's not supposed to be bright, but if it's in a dark room, it may be bright enough to still cause pain and issues and things like that. So it all depends on the context and the situation. So that's why I think lighting is pretty cool. Your pupils control that. Your pupils adjust. They open up or close in order to let more or less light in. Okay, so that's why I find illumination to be very interesting. This idea that the further you are from something, the less bright it is. Look, that's pretty intuitive. I'm sure you guys were aware of that. If you have ever been hit in the face with a bright light, you either get far away from it, or you look away from it, or you close your eyes to not let the light in. Like we know how this works already. But what we may not have considered is what goes into designing the lighting of a room, okay, or a building, or for a parking lot, or any of these things. A lot goes into it, okay? A lot goes into it. So when you're doing these lighting calculations, there are some design considerations to take into account, and we'll get into some of these points, not all of them. I want to go through what I think is vital, okay? So there are 6 different lighting terms that if you decide to look into this on your own, you'll see these types of things. But this is what you want to consider when designing. Okay. So to figure out how much light you might need, you're gonna have to figure out some of this stuff. So luminous flux, I'm gonna give you some broad definitions. Luminous flux is how much light you get from something in general. Okay. It's how much light you get. So look at these light bulbs over here. How much light is this light bulb giving me? Period. Okay. Then you have luminous intensity, which is the same thing as luminous flux, except in a specific direction. So luminous flux is how much light is this thing giving out, and it doesn't matter the direction, it's how much light it's giving out, period. Luminous intensity then is the next step up. It's focusing on a particular direction, okay? And that matters for the next thing, which is illuminance, okay? Illuminance is how much light falls on a specific surface, okay? So let's say you have a tabletop, you have to light up the room. How much light is actually hitting that tabletop, okay? Then you have luminance, which is how much light comes off of something per unit area, okay? So let's say it's hitting the tabletop, okay? And now it's bouncing off of the tabletop and hitting your face, okay? How much per unit area is that light? And then you have color rendering and color temperature, and these are more design creative aspects, okay? So color rendering is how much color is visible, if that makes sense. So I'm going to use some lighting terms here. You have things like contrast, and what contrast is the difference between bright and dark. Okay, but then color rendering is how much color pops. So let's say you have a black and white picture. In a black and white picture, color rendering is 0. You can't see color. All you see is black and white. So the higher the color rendering, the clearer colors will be. That's what that is. And then color temperature is warmer or brighter colors. I don't know if you've heard that term before, but warmer colors are your yellows, your reds, and cooler colors are your blues. Okay, that's what they mean by color temperature. So this all goes into designing a room, and you have to consider things like mood, atmosphere, stuff like that. Okay. And then you have your glare. These are other things to consider. You have glare. You guys know what glare are. The working plane is where most people are going to be at. And then is it indoor or outdoor? That matters a lot because if you're indoor, you have walls. The walls let light bounce off of them and you will get more light out of it, quote unquote, right? And then if you're outdoor, you don't have those walls. So you don't have the luxury of getting that extra lighting. So you may need more light if you're outside. Okay. Okay. So now that we have the basic ideas of what goes into it, now let's start taking some things into consideration. We're designing a room. We gotta set up safety. We gotta make sure things are bright enough to point out where we want to go. If you notice in the schools and basically every other building that has any emergency exit, the exit signs themselves have lights in them. Okay. If God forbid an emergency were to happen, the exit signs would be clearly lit so that you can know where I need to go, where the exits are. So that's what they mean by safety. Okay. And they might have some emergency backup lights that, guide you towards the exits if that was to be the case. Okay. I want to focus more on the lighting schemes. So the lighting appearance and the energy efficiency, these are some things you want to talk about. But I want to get more into the actual luminance calculations. Okay. So next thing you want to consider is the type of light. Okay. So a luminaire, you're going to see this term a lot. A luminaire is the whole lighting unit. Okay. So think about classrooms in the hallways in Pennsauken High School. Okay, you see them on the ceilings. You see those panels. Okay, those panels each have two fluorescent tubes in them. The fluorescent tubes would consider to be the lamps. Those are the lamps. But the whole thing, the whole panel with both tubes in them, we're going to call that a luminaire. Okay. So a luminaire is the whole unit. And let me see if I can, they do have an example of it down here. So I can show you exactly what I mean. Okay. Right there. Okay. And let's get rid of this. This whole thing. Okay. This whole thing would be a luminaire. Okay. Normally they have two tubes in them. They're just showing one for example purposes, but most of them have two tubes in them. The tubes will be considered a lamp, and then the whole unit is a luminaire. So that's what they mean by luminaire. Okay. Now, when considering these calculations, we have to figure out what type of luminaire we have. You have direct lighting, semi-direct, general diffuse. You have indirect lighting, semi-indirect, and direct indirect. Okay, it's a little weird. But direct would just be you have a light on the ceiling and the light is pointed down. Okay, so that would be something like this or something like this where the lights are pointed straight down, right? But then you might have a indirect. Okay, an indirect is just where the light is pointed up instead. Okay, you might do different calculations. So let's say something like this. Okay, you have the black holding piece at the bottom, and the lights are pointed upwards. Okay, so they go, even though it spreads out everywhere, it mostly goes up and it bounces off the ceiling and comes back down. General diffuse is just exactly as the name implies. It would be something more like this, where you have a fixture where the light is allowed to just spread everywhere. There's no cover on the top, there's no cover on the bottom. It just hangs and it spreads around everywhere. Okay. So depending on the type of fixture you have, you will get different results for the lighting. Okay. Now you have to take into consideration the room shape. So there's this thing called the working plane. The working plane is where most people in that room are going to be doing their quote unquote work. So let's say you're designing an office space. In that office, you're going to be working mostly where? Usually at a table. Okay. So the height of that table is usually going to be your working plane. If you're in a factory, you have to consider, okay, where at what level are most of the factory workers going to be at? That's going to be your working plane. That's what they mean when they say that. Okay, that's what they mean when they say it. You also have to take consideration the dimensions of the room, because again, like I said before, the walls you can use them to your advantage. The walls bounce light off of them, and you can use that to make a room brighter while using less light. Okay, so you have to take consideration that. You also have to take into consideration the color on the walls. Okay, why does that matter? Well, we know that the color black absorbs a lot of light. The color white reflects a lot of light. So if you have black walls, you're going to get less light than if you have a room with white walls. Okay, so the color matters as well. So you have to take that into consideration. Okay, and this is exactly what I mean by that. So depending on the wall, you may have different reflectances. So reflectance is just a value, okay, it's usually percentage that gives you how much light is going to be reflected of the wall, or how much of the light that hits the wall, how much of it is going to bounce back. Okay, that's reflectance. Okay, how are we doing on time? I don't want to make this too long. Okay, okay, because this is just for creative purposes. Because this is so when it comes to illumination, is if you already can't tell, this can get very complicated very quickly. Okay, so there are no calculations or worksheets that I'm going to have you do with this. This is just for your information. This I don't think this does lighting justice. Okay, they just talk about illumination is brightness and call it a day. I wanted to give you a little more information on it for those of you that may be interested in interior design. Okay. So the wall reflects light. If you have windows, light comes in from the windows. Light also reflects off the windows. So you have to take that into consideration. Okay, light also bounces off the floor, and then this is your working plane. Okay, this table, this is where you're going to spend most of your time working at. You want to figure out, how the lighting affects the table specifically. Okay, so now you have that. Now you want to, after you do all those lighting calculations, now you want to figure out mood. Okay. Now you want to figure out mood. Okay. You have these things called accent lighting, which focuses on decorative lighting. Wall light, ceiling light, light color is a big one. Okay. Light color is a big one. So if you don't believe me, let's see. If you don't believe me, well, that's why cloudy days, sunny days, sunset versus sunrise. In different situations, you have different lighting, and it affects your mood. Most people on cloudy days might feel a little less energetic. They might be a little more moody. They might be a little sadder because it's cloudy. People tend to be happier for one reason or another on sunny, bright days. Okay, it just puts you in a good mood. Okay, so depending on what environment you have, you may want different types of lighting. If you're at a movie theater, for example, usually they turn the lights off in the movie theater, but you don't necessarily have to do that. You could change the lighting color. Okay, so cooler colors tend to be more relaxed, calmer. So maybe you might have like a bluish tint or something like that. That might calm you down. That might be good for a movie. If you want more energy, you want more social interactions, you might go for a warmer color. Warm being like the yellows, the reds. Okay. So lighting mood can affect certain things as well. All right. So you have to take that into consideration. Okay. And then you have, and I believe that's everything. Okay. Lighting distribution. Okay. If you want to get more fancy schmancy, with different lighting fixtures, remember with these, the semi-direct, indirect, general diffuse, you also have these light distribution curves which tells you how the light is spread out depending on either the angles. So in this case, it's looking at angles. So if you're directly in front of it, which is 0 degrees, how bright is it? If you're on the side of it, how bright does it get? And things like that, how light spreads out, okay? You also have distance, how far you are from the source. So you have angles, you have distance. You can take all these things into consideration to see how light is distributed from different sources. And you use that to do your calculations as well, okay? And they've made these tables to make life easier for some of these designers that base it off of power. So let's say you know what type of room you want to design. So, for example, they have hotels, stair corridors, offices, garages, theaters, buildings, malls, classrooms. How much lighting do you need? And there's a general range. They might have this is how much light you typically need for this source. And based off of that, they'll recommend you, okay, this is how much power you need per area to satisfy that. So instead of having to calculate, all these different lighting fixtures and things like that, they can just say, okay, this is how much light you would need in this room. Buy, light bulbs that will give you this much power, and then depending on the area, how many of them you need. And that's how that's why the panels are set up in a grid. They're set up in the grid to cover as much square footage as possible to meet these demands. Okay, and that's how they do that. And then you start to get fancy with these fancy equations. These equations take into account certain things. So it's not as simple as doing these calculations. You have to take into account your other factors. The light bulbs, they wear out after a certain time. Angles, walls, again, absorption factors. These things, they take them into consideration in these things, okay? The maintenance factor and the utilization factor cover those things, okay? And then, again, room, cavities. Things can get complicated very quickly, okay? But all of this goes into lighting calculations, okay? For those of you that are interested, I will be posting this presentation that covers this lighting stuff, as well as a YouTube video that goes along with it that might give you a better summary, okay? But that's it for today. I just wanted to cover things that go into light. You may have not ever put too much thought into it, but a lot goes into designing the lighting that goes in a building, in an office, in a theater, okay? In Pennsauken High School, when they were building the school, they had to do those calculations. How much lighting do we need in these areas? Where should we put them? All these things, okay? All of that goes into the considerations, okay? So happy Friday. I wish you all the best. There is no work for today. This is just for your interest. If you're curious, which I know some of you may be, look into it. It's cool stuff. Hey, but enjoy the rest of your day. Be safe and take care.